Greetings, chemistry students. Today we're going to pick up the PowerPoint where we left off yesterday. Got a few different things to talk about. The first one is the difference between a scientific theory and a scientific law. And these things are fairly easily confused because these terms have other meanings in everyday speech besides what we mean in a scientific concept. Uh, from a scientific standpoint, a theory is an explanation of a scientific phenomenon. In other words, it says why something happens. And if you think about this, some scientific theories are global warming, the Big Bang Theory, atomic theory, evolutionary theory. The Big Bang Theory is an explanation of how the universe came to exist. Evolutionary theory explains the development of life on planet Earth. Global warming is an explanation for why temperatures on Earth are slowly increasing. Atomic theory is an explanation for how atoms work because you can't actually see an atom. They're literally too small to be seen. So theories are explanations of why things happen. So they answer the question why. A law, on the other hand, is a statement of what happens in a given set of circumstances. And some scientific laws you might be familiar with are Newton's three laws of motion. First one saying that an object in motion will stay in motion and an object at rest will stay at rest unless acted on by an outside force. Second law says force equals mass times acceleration. And the third law says for every action force, there's an equal and opposite reaction force. Nowhere in Newton's laws does he say why those things happen. It just says what happens in a set of circumstances. There's the law of universal gravitation, says that the force of gravity is proportional to the masses of the objects and inversely proportional to the distance between them squared. There's the ideal gas law that says pressure times volume equals moles times a constant times the temperature in kelvins. So those are laws. They tell you what happens. They answer the question what. So theories and laws are two different things. Theories don't become laws. Laws don't become theories. A theory in a scientific setting is not just a wild guess. It's not just a hypothesis. These are well supported and documented things backed by evidence. Both of them are subject to change in light of new evidence. I mean, obviously, if we discover something new that seems to imply something else is the case, then we'll revise the theories or the laws as necessary. For instance, Newton's laws of motion we have discovered don't really apply to electrons, but they work well enough for everyday situations. All right. Next, I've got this little map right here, and I want you to look at it and take a minute, pause the video, and see what you think it's about. So these three countries on this map are the three countries in the world that do not use the metric system. And those countries are the United States, Liberia, and Myanmar, also known as Burma. And Myanmar is converting to the metric system from their Burmese customary units. Liberia and the US use what's called US customary units. The metric system is a subset of something called the SI system, which is what scientists use. It's short for this French phrase that I'm not going to begin to butcher here for you, but it means the International System of Units. And it's very similar to the metric system, but with a few minor differences. But the SI system has some base units. For instance, time is measured in seconds. Length is measured in meters. A meter is a little bit more than a yard. Mass is measured in kilograms. A kilogram is 2.2 pounds. And temperature is measured in kelvins. And kelvins, if you're not familiar with that, it's degrees Celsius plus 273. So if it is 20 degrees Celsius outside, it is 293 kelvins. The Kelvin scale, we'll talk much more about it later, but 0 kelvins is what's called absolute zero. 298 kelvins is considered to be room temperature, or 25 degrees Celsius, around 78 degrees Fahrenheit. That's considered room temperature because that term was defined before the invention of air conditioning. This is another map. It looks similar to, but slightly different from the other one that you saw. This is countries that use Fahrenheit instead of Celsius, or no country uses Kelvin as their normal temperature scale. That's pretty much restricted to science use only. Um, the countries that use Fahrenheit are largely restricted to the US, Liberia, which is a unique case. It's a fascinating place if you research its history. And then some of these places that are very popular with tourists as destination spots from American tourists. Let me be more specific. All right, so that was the SI system. Next, all the stuff we're doing today should largely be a review of things you've seen before. Next, we've got the scientific method. You probably have heard this a million times. The scientific method is just the way scientists solve problems. It's just a logical way to solve any problems that you have. So, when you want to solve a problem, you should first state whatever problem it is that you're trying to solve, identify what it is you're trying to do. Then you should formulate a hypothesis, which is a testable prediction based on observations and any prior knowledge you may have. Then you conduct an experiment where you test it, and you should have variables, which are things that you change, and you should have controls, which are things that you keep the same so that you can identify what has the intended effect. Then you analyze your results, you see what happened. Did you solve the problem? And then you draw your conclusions, and then you should publish your findings. If you figured out a way to solve a problem, you should probably tell other people. Um, if you've discovered a way to create a coronavirus vaccine, you should probably share that information with other people. That would be really helpful so we can all get back to school in person. Right? So, this is stuff you've seen before, hopefully. The last thing we're going to look at for today is density. And density is the ratio of an object's mass to its volume. And since that's a ratio, you might say, oh, that involves dividing. There might maybe be a formula for this, and you would be correct. The formula, it's found on your reference tables on page 3. It's the very first formula here. It says D equals M over V. And if you look over here, it tells you that D is density, M is mass, and V is volume. So you don't have to memorize this formula. It's there for you. Density equals mass over volume. Whenever you come to school in person, we're going to do a little density lab. On your reference tables, on page 2, it has a whole bunch of different substances and their densities. And then on page 1, towards the bottom, it's got some metals and their densities as well. The interesting thing to note on the last thing on page 2, it tells you that the density of water is 1 gram per cubic centimeter. And fun fact, also a cubic centimeter is also the same thing as a milliliter. If you have a box that's 1 centimeter by 1 centimeter by 1 centimeter and you filled it with water, it would hold a milliliter of water. And that water would weigh 1 gram. So water has a density of 1 gram per milliliter or gram per cubic centimeter. Things that have a higher density than that are more dense than water. If you look at this chart, and things with lower numbers than 1 are less dense than water. The thing about density is it's what's called an intensive property. In other words, it doesn't matter how much of the substance you have, it's just the ratio. The more mass you have, the more volume you've got of it. So the proportion stays the same. So if you're talking about aluminum, which has a density of 2.702 grams per cubic centimeter, it doesn't matter whether you're talking about a tiny little piece of aluminum foil or you're talking about a giant block of aluminum. Its density is the same. And the last thing about density for you to note is that objects of lower density float in objects of greater density. So since aluminum has a density of 2.702, it would sink in water because water's density is 1, and it would float in mercury because mercury has a density of 13.5. So this is what density is. We're going to do a little bit more work with some density problems. So, as an example, if we were to try and solve the problem, what is the mass of 1,300 cubic centimeters of gold? We're going to use the formula that D equals M over V. And then the density of gold on your reference tables is 19.31. The mass of gold we don't know, and the volume of gold is 1,300 centimeters cubed. This is in grams per cubic centimeter. So if we're trying to solve for mass, we're trying to find the mass, then we need to multiply our density times the volume. So you would kind of cross multiply these. You could pretend that there's a 1 under there and cross multiply. So what you get is that mass equals the 19.31 times the 1300, and I'm coming up with an answer of 25,103 grams. There we go. So that would be an example of one problem we could solve. Let's take a look at another one. Let's say I asked you what is the volume of 80 grams of ethanol. Well, density equals mass over volume. So you look on your reference tables, you find ethanol, which happens to be the first thing on the top of page 2, and its density is 0.7893. So 0.7893 grams per cubic centimeter equals mass 80 grams over volume. Well, we don't know the volume, so we can cross multiply here, and we get 0.7893V equals 80 grams. So to get volume all by itself, we would then divide both sides by 0.7893. And we would get that the volume equals whatever 80 divided by 0.7893 is, which is 101.4 cubic centimeters.